So the first one is the molecular formula. Now this shows the actual number of each kind of atom in a particular molecule. Okay? So for instance, we're going to talk about this one, C2H6, which is called ethane. Now a molecular formula like this shows you that there are 2 carbon atoms and 6 hydrogen atoms. And so that is the chemical formula for the molecular formula for this chemical. Okay? So very, very easy. However many atoms you have of that particular element, just put them all together and put the number, and then that's what the molecular formula is. Now the empirical formula is slightly different and slightly more confusing in that it shows the number ratio of atoms. Okay? So what it does is it takes the smallest ratio of atoms, and that is your empirical formula. Okay? And that's often used in very long polymers, like cellulose and things, because it'd just be impossible to write out every single number. So we just simplify it for analysis purposes. So for that ethane again, we had C2H6, right? Now, there's for every 2 carbons, there's 6 hydrogen. So we can actually reduce that ratio to be 1 to 3, right? For every 1 carbon, there's 3 hydrogens. So then we can just write this as CH3. Okay? And that's what we've got here, right? So it's just the lowest ratio. And often you won't encounter too many of these empirical formula, but it's just here just to show you in case it does come up. So empirical formula, the lowest ratio, and it's quite confusing when you look at it. And lastly, this is my favorite one because it shows you the most about a particular chemical. It's the constitutional or structural formula. I use this one all the time. And it shows the arrangements of atoms in a molecule. So the molecular formula showed you how many of a type of atom were in a molecule. The empirical formula showed you the ratio of atoms in a molecule. And this one actually goes beyond the molecular formula and shows you what it looks like. Okay? So here we have the ethane molecule again. So you've got 2 carbons bonded together, and then you've got the 6 hydrogens all around. Okay? And that's what it would look like. Okay? So that's what a structural formula would look like. So sometimes, if we don't want to draw all of this, we can have a sort of abridged version. And so you could kind of reduce it down to a sort of shape like this, where you've got repeating elements sort of like this, just to reduce the complexity, because we don't want to keep drawing this all the time. So you can actually reduce it or get it down to its most significant parts. So write out the molecular formula for aluminium hydroxide. Okay? Aluminium hydroxide. And remember, we need to know the valency of these chemicals. So aluminium has a valency of +3, okay? And OH has a valency of -1, all right? Therefore, in order to achieve a neutral chemical, we need 3 OH ions for every 1 aluminium ion, okay? And so we get AlO3, okay? OH3, sorry. And the name would be aluminium hydroxide. We don't say trihydroxide because there's really only one way that we can form this, so we don't need to specify anymore. Okay, so that's the molecular formula for that.